everyone. Welcome to OPN402. My name is Andrea Morosi, and I am a senior SA engineer at AWS. And I work on the Powertools for AWS Lambda team. I build and maintain the product, and I also set the direction for all the runtimes of Powertools. Before we get started and we discuss the agenda, I want to start with a question. How many of you have heard about Powertools for AWS? Okay, nice. Okay, so this is probably a session that I hope you'll find interesting. The idea of this session is for me to go through some of the common practices or problems or challenges that I see customers working on AWS Lambda approaching and facing, and show you how Powertools for AWS can help you mitigate some of those challenges or use some of those features. Not all the features may be relevant to your workloads. That's fine. This is more like see this talk like as a collection of different things and take what you think is most useful for you. I'll try to leave a few minutes also at the end of the session, so if you have questions about the product, happy to answer them. So let's get started. This is the agenda for today. I'm going to do a very short introduction about Powertools for AWS Lambda for those of you who didn't raise their hand, or maybe a refresher for those of you who know it. And then I'm going to talk about structured logging, event handling for APIs, idempotency, batch processing, and then I'm going to share some links to the product roadmap and Q&A. So let's get started. The software development lifecycle in most workloads looks something like this. You start with a phase in which you plan and design your use case and your workload. Then it comes the building phase. This is the part that we all like the most. It's where we build and we architect our solution. And then you publish your workload in production, and then it starts the operational moment. If you have ever done an assessment of a workload, such as the well-architected with the serverless LANs or similar, this is something that you do ideally before going to production. It's time that you spend looking at your workload, asking yourself and your team a bunch of different questions to see if your workload is well-architected, highly available, fault-tolerant, and so on and so forth. Now, not always this happens before you go to production. In reality, sometimes timelines are tight, and you do this after you are in production. All this to say that essentially you do this after you're done building. Now, what if there was a better way to bake into your workload since the building phase some of those best practices so that you don't have to go back and rework your code, refactor, and add things to your workload? What if there was a way that you can adopt some of those best practices? And this is where Powertools for AWS Lambda comes in. Powertools was born, quote unquote, in 2020 and started with what we call core utilities. Those are utilities that are available in all the Powertools for AWS languages and revolve around observability. I'm talking about JSON structure logs, I'm talking about business metrics, and I'm talking about distributed tracing. Those are all utilities that allow you to emit data from your serverless workloads so that you can essentially ask yourself and answer arbitrary questions about your workload. But then we realized that we could do more. And we started launching new features and adding more functionalities to Powertools. We went into batch processing with partial failure reporting. We went into config and secrets and parameters management. We started doing idempotency, input-out validation, and so on and so forth. Everything started with Python. So Powertools was launched first with Python. This is also the version of Powertools that is more feature complete. But then we also added more languages such as Java, TypeScript, and Node.js, and .NET. As of today, Powertools runs in over 200 billion Lambda functions per week, and 40% of our functionalities are contributed by the community. Powertools is an AWS open source project that is fully maintained and developed on GitHub. Essentially, the code is MIT license. You can go and see the code, you can open issues, and you'll find me and my team answering those issues and reviewing your PRs if you would like to contribute any of them. So let's start with some more specific use cases. Let's talk about structure logging. Now, if you're working on Lambda, chances are that you're emitting logs. In the simplest form, emitting logs in Lambda means that you emit something to standard out or standard error, and AWS Lambda sends this information to CloudWatch. This is the simplest form. Of course, you can send your logs elsewhere to third-party observability providers or your own indexing platform. But essentially, today we're going to focus about where you send the logs or how you consume them, but how you create those logs. And there are, let's say, 4 general ways of doing logs in Lambda, or in general in your code. The first one is the most simpler. You use a logging library. For Python, it would be the logging library. For Node.js, it would be the console.log. But essentially, you set a log level and you emit a string. When this goes into CloudWatch, you will know that there is a request ID, there is a log level, and then there is your message or your log payload. Now, this is good if you're debugging or running things manually, but if you ever run something in production, you know that it's kind of hard to consume these logs because there is a lot of metadata that it's hard to parse and it's hard to make sense of. And this is an example of what I was talking about. Now, as your workload evolves and as you get better at logging, you might think, okay, let me try to create an object or a dictionary, depending on the language that you're using, and let me start adding keys to it and log it as such. Just like before, since you're using the default standard output log, you will have also the log level, the request ID, the timestamp, and so on. There are also teams who decide to do what is called canonical logs, which is essentially a log that has additional keys and essentially allows you to create a different structure. But then eventually, most likely, if you're using CloudWatch, especially, you will get into structure logging. Structure logging essentially allows you to create JSONs and emit them to standard output so that through CloudWatch insights, you can index those logs and make queries and filter them using the discoverability of those fields that are part of your log. Now, if you've been paying attention to the code samples that I'm showing in the slides, you will have noticed that they get more complex and more as I go and add functionalities. This is because usually this is something that what at AWS we like to call undifferentiated heavy lifting, but essentially it's a fancy word to say you're adding a lot of boilerplate code to your code base. Now, as I mentioned before, enter Powertools. Powertools Logger is the first and one of the most useful, in my opinion, library features in our toolkit, which essentially allows you to create a standard logger that uses what we like to call sensible defaults, and is also easy to extend. In its simplest form, allows you to set up a service or, let's say, like a high cardinality key that you can use to filter your logs based on a specific workload. And then it also supports other features like the log level and so on. This is a log that you'll see if you use Powertools. As you notice, there is no string anymore. There is no timestamp, request ID, and so on. Everything is part of a JSON object that you can now use to do queries in CloudWatch or in other third-party solutions. Wherever you're using your logs, you can now say, I want to see all the logs that have a level error, for example, for this specific service and this specific workload. And you can get insights on your workload really easily. Now, with Powertools, you can also do other things like adding contextual information, essentially adding more information about a specific request of your function. I'm showing you here a decorator. This is a Python-specific example, but in other languages for Powertools, there are equivalents that look similar like this. But essentially, you're telling the logger, look, this is my entry point, this is my handler of the function, and if you know Lambda, you'll know that the second parameter is the context that contains a lot of the information about your function. For example, the function ARN, the request ID, and a bunch of other fields like the function name, memory size, and so on. You can also set correlation IDs. So for example, if you want to get visibility of a request end-to-end, as it goes from, for example, your API gateway to your Lambda function, you can set a JMS path, like I'm showing you in the slide, to essentially say, hey, grab this field from the request, like the request ID, and add it to all the keys in my logs. Now, we like to say that logger is an opinionated logger. We bring a format and we bring specific keys with specific names. But we understand that also customers like to have their own formats, either because they like it or because they have requirements to do so. And so it's very easy also to extend this logger and bring your own formats. This is an example of that I'm showing you, that you can essentially extend the logger and create a different format that the logger will use to create those logs. As you see, I'm rearranging the keys, I'm renaming them, or I can also remove them. And then the logs will essentially use that format that you have specified. Now, something that I'm seeing more and more from customer is the concept of wide logs. Now, if you're using Lambda and CloudWatch, you will know that at scale, things can get pricey because you're emitting a lot of different logs for all your workload, for all your requests. So there is this practice of using what we call wide logs, which essentially allow you to emit a single log per execution, or maybe 1 or 2 logs per invocation, and add keys or different metadata as the request progresses. Usually, you will have different logs, like when the request starts, you will have the bug log, and then you do something and you emit another log, and then when you're done, you emit another log. Think of this and replace it with adding keys to your logger. Since you have a shared state, which is this logger class, you can go and enrich your log entry, and then at some point towards the end of your request, you can just dump everything to standard output, and you will have a log that looks like this. Essentially, this makes not just things cheaper to run because you're emitting less noise and less logs, but it makes them also less noisy because now you don't have to correlate all those different logs and you don't have to query different log entries, but everything is in the same log. If you have a request ID or if you have a function name, you can get a specific request and you will have all the information about that request in a single entry. As I mentioned, this is something that I'm seeing customers experiment and use more and more. And it's pretty easy to do also with Powertools. So let's move now into a different topic, event handler. So whenever you work with serverless applications, chances are that you might be building an API. This is a pattern that is pretty common. You have an entry point. Here in the slide, I'm showing Amazon API Gateway, but it could be ALB, or a function URL, or a VPC lattice, or basically any kind of entry point that accepts HTTP requests. And then it's backed by a Lambda function that acts as a compute layer, right? When you do this, there are a lot of things that you need to start thinking about. You need to think about routing. You need to think about serializing the input and the output of the request. Maybe there is some compression. Maybe there is something that you need to validate. If you're working in a team or in a large organization, you might want to emit an OpenAPI spec and a Swagger UI. Maybe you want to look into middlewares and then the observability that we talked about just now. Maybe your workload needs to be idempotent. So essentially what I'm saying is there are a lot of things that for every time that you build an API, you need to be doing. A common question that I get, but I bet a lot of solution architects at AWS get is how many functions do I need for my workload? Historically, I want to say that our guidance, our prescriptive guidance, tries to go into you need a single purpose function. You need a function that does one thing and does it well. This is true, and it's really good advice, to be honest, but life is rarely that black and white. The reality for most customers is that this is a spectrum that has different trade-offs and different choices that look different for different workloads. So what are the things that you should be thinking about when making this choice? So if you have a single function, what I call Lambda monolith or Lambda lith, you're probably having a simple CI/CD pipeline because you're deploying a single function. This is usually true for brownfield applications. So if you have a workload that you were running elsewhere and you're now putting into Lambda, you're probably doing something like a lift and shift, or maybe it's a workload that you want to know that you can off-ramp into containers. So essentially you have a single function that you're deploying. Now, since all the different routes of your APIs are in the same function, chances are that this is going to lead to a lower cold start chance because all the routes are going to the same pool of execution environments. So there is probably less cold starts. Obviously, this is dependent on your request patterns, but this is generally true. At the same time, more routes means probably more code. So you're probably loading a lot of more dependencies, a lot of more modules, and this means that whenever there is a cold start, it might be slightly higher. You need to also start thinking about scaling and quotas because you have now a single resource that is being used for a lot of different use cases, a lot of different requests, so you need to really pay attention to this aspect. Another thing that, as I hinted at earlier, is the permissions. So if this function is talking with a lot of different services, like databases, queues, and so on, this function now needs to have access to all those things. And so there is a broad permission model. But like I mentioned, life is easy and nice because you have a simple function that you're deploying. Whenever you make a change, you deploy one thing, and it changes everything. On the other end of the spectrum there are microfunctions. So you're now buying into complexity. You need to now think, whenever I'm making a change, I need to understand what I need to deploy and where, what is changing, and there is a lot of moving parts. So this can be harder to reason about. Since you have different routes with different purposes, you might have a higher cold start chance depending on which route is getting hit, because not all the different routes on your API are as popular. Maybe you have a very popular and very hot path, but then you also have other paths that are used much less, and those will probably have cold start more often. But now, since your function has a single purpose, it's also smaller, and it's probably using less dependencies, less code, less modules, so the cold start, whenever it happens, it's much quicker. Each one of those functions, it's easier to reason about because it scales independently. You can really, if your workload is, let's say, cloud native and is using a single function, you can really reason about every single route and understand what is the scaling pattern of each one of them. So this is something that if you can leverage this, it's really interesting. You also get granular permissions because now the function does one thing and one only. But then you need to deploy a lot of things. So let's look at some code now. If you're using the monolith pattern, chances are that your function is going to look something like that. You're going to have a huge if-else statement, maybe a switch statement, but essentially you're looking at the event, you're looking at the payload, and then you're doing, what if the event has this path or this header, and maybe there is a parameter that I'm expecting. If none of them matches, I need to throw a 400 request or a 500. Then I need to try except to catch all the exceptions so that I return a 500. So essentially, again, there's a lot of boilerplate code that you're building and a lot of edge cases that you need to be thinking about. Again, like you will notice for a lot of the things that I'm going to talk about today, none of this is rocket science, to be honest. Like if you spend time and effort, you can really hone this pattern and do it. But why do this? Why you want to maintain this code when there is a library that can do this for you so that you can focus on your business logic? So this is another example where Powertools can remove a lot of your code and essentially allow you to do those operations in a way that you can essentially inherit and leverage all the shared knowledge of a bunch of different customers that are already running this in production. A lot of those edge cases are already ironed out for you, and essentially allows you to focus on your code and have some hooks, some decorators, some annotations to annotate your code and run it whenever there is certain conditions that are being met. Here in this example, I'm showing what is called an API gateway resolver, which is essentially a class that maps to the event of API gateway. And then this also has some decorators that you can attach to different functions. And whenever there is a different type of request with a different payload or a different path, it runs certain portions of your code rather than others. You can also customize it. You can define some, let's say, default routes. For example, whenever none of the routes that I have defined matches, I want to run some specific logic. You can also do validation. So if you're familiar with Python, this is compatible with Pydantic, which is a library for validation. But if you're using other languages, maybe you like Zod and so on, the idea is that essentially you define some schemas, some models that the request that you have is expecting, and we run them for you during the logic. And if the validation and the parsing passes, we run your code, and you can have a guarantee that the payload that your function receives is exactly the one that you were expecting. As I mentioned earlier, some teams also might want to do OpenAPI. So with Powertools Event Handler, you can annotate your routes, you can add descriptions, you can add examples, you can even use OpenAPI extensions. And once you have annotated your code, we generate the OpenAPI schema for your entire API that you can use directly. And you can also enable the Swagger UI so that you can essentially test your functions and your API similar to how you are used if you're using OpenAPI. We also have other different features like cross-origin requests, compression, binary responses, and middlewares. Now, something that I think is pretty interesting is that, okay, now let's say that even if you're building this on your own, you have defined a certain model for API gateway. But now, for example, you need to move your API behind a different entry point. Maybe you want to use ALB. If you worked with any of those services, you will know that there are a lot of different subtleties that change the payload in different ways. So you need to now handle those things. With Powertools, all you need to do is essentially change an import a different resolver, and the rest of your code stays the same because we handle those subtleties for you behind the scenes, and we just give to your code the payload that you were expecting that is specific to your use case. So this is Event Handler. As of today, it's available in Python, but it will come also in the TypeScript version of Powertools in Q1 2025. Let's talk about idempotency now, different topic. So what is idempotency? An operation can be said that it's idempotent when it's run multiple times with the same inputs and yields the same results, no matter how many times it's run. This is something that you might want to do, for example, if you're processing a financial transaction or an order, basically something that you want to run a function, but you don't want to run the side effects for it. Now, the word is asynchronous, so this is hard to do usually in Lambda because you need to start thinking about, what if my Lambda function times out? What if I receive 2 concurrent requests? What if I want to run the function only after, I want to consider an operation idempotent only after a certain amount of time? So those are all things that you need to start thinking about in a distributed system like Lambda. So in a normal case, if you have different requests, you run this operation multiple times. This is when your operation is not idempotent. This is usually costly and can lead to also side effect. If, like I mentioned, if you're doing a purchase, an order, you don't want to charge the user twice. And so you want to make your code idempotent. So essentially, you need to implement a logic that looks at the request, keeps some state in a separate place, in a persistent store, because Lambda is stateless. And whenever you get a request, you want to compare this payload with what you have saved and check, have I seen this request? Is it something that I need to process again? If it's a new request, you process it. Otherwise, you just return the response from the previous request if it's idempotent. Now, let's get more into specific. When you're doing this in Lambda, you get a request. This is the happy path. This is the first time you see a request. You look at the event. You set the state in storage, like DynamoDB, for example. You set this record as in progress. This is also called a lock, basically, so that essentially whenever your request is marked as in progress, if another request comes later, we know it's in progress and we bounce it. Then we run your code. This is where you run your logic, your side effects, and so on. Then we store the result of this response, and we return the result. This is the simplest option. Now, what happens if you receive the same request again after? Again, we look at the event. This time, we check what's in the persistence layer, and we see that there is a request with the same payload that we just saw a few seconds ago or a few minutes ago. In this case, we don't want to run your code because this will cause different side effects. So instead, we get the result that we have saved in DynamoDB, and we return that instead by passing your code entirely. Like I mentioned, what happens is your function is scaling and you have concurrent requests. At this point, instead of doing what I described earlier, you want to, if there is a new request, we check the payload. We see this time that something is either in progress or is already being processed. In this case, we just, if it was in progress, we simply return a 500 or a 400 rather, better, because essentially it's saying, I have seen this request, but it hasn't finished processing, so I need to hold on and see what happens. What happens if your code crashes? So your Lambda function raises an exception. Maybe your lock now is in an inconsistent state. Before it was in progress, your Lambda threw an exception. What the idempotency utility does is it wraps your function and it notices that you're raising an exception and deletes the lock so that the subsequent request will be accepted as a new one. Now, getting more into specific, how does this work? Ideally, you want to use something that is the least invasive possible. You want to wrap your function or your code, the code that you want to make idempotent, with something like a middleware, a decorator. You want to make it idempotent so that your logic stays the same, and we just essentially looks at the input and outputs. This is ideally a pure function. So this is what happens. We provide a decorator, we save the record, and then we run your code. We save different fields in the database or in persistence layer so that we can keep track of the expiration, of the in-progress expiration, the status, the response, and so on. This is a code example of the idempotency in action. As you see, I'm making my entire Lambda handler idempotent by decorating it. I'm instantiating a persistence layer. Like I mentioned, this is DynamoDB for this example. And I'm running the code and saving the results. Now, in a lot of cases, this can be a good idea, but in probably most of the cases, it's not. And the reality is, the reason why this is not is because functions, or rather payloads, have fields that are usually changing often. If you're doing this for an API, for example, you will have a request ID or a timestamp that will be different for each request. So essentially, your function will never be idempotent because the utility will see that the JSON is different and say, this is a different request. Some of the fields are the same, but some are different. So this is not important. So it's usually a good idea to instead narrow down the scope of the idempotency and make idempotent only some of the logic that is truly critical that it's not repeated. For example, if I am processing an order, maybe it's not the entire function that should be made idempotent, but only the logic that is actually processing the order. This way, your function is still being run every single time, but the side effect that I care about and the side effect that I don't want to be repeated is made idempotent. As you can see here, I'm also introducing the concept of configuration. We support JMS path expressions, which essentially allow you to extract subsets of the request and say to the utility, look, no matter what I see in the payload, what I really care about for the purpose of the idempotency, it's just one or a few fields. And those are the fields that will be used to derive the idempotency key. The idempotency key is essentially a fancy term to say we create a hash, a deterministic hash for your payload, and we store it. And this hash identifies the request. There is also another concept there, line 22, which is we're making the utility aware of the Lambda context. Why is this important? Because the Lambda context holds information about the remaining time of a Lambda function. So the context has a method that's called something like get remaining time in milliseconds, which essentially tells the utility how much time the function has left before it will time out. This is important because if the persistence layer doesn't hear back from the request, it means that it has timed out. And so if a later request comes in and this time has passed, we can already assume that it was timed out or something else happened. And so we actually need to run the request again because it's never going to come back. Now, you can also configure more settings. If you've been paying attention to that example, you might have thought, hey, but if I'm using an API like API Gateway, the payload might be a JSON stringified payload. So how do I do that? Because it's a string. So for example, you can use functions like Powertools JSON, which is a custom function in the JMS path module that essentially does the parsing for you and transforms into a dictionary. What I'm trying to say here is that we have different utilities that allow you to parse different types of data formats. We support base64 encoding, JSON, and you can also provide your own transformation. So that it doesn't matter if your payload is encoded, compressed, or whatever, you can still make it idempotent in a few lines of code. You can also use local caching. For example, if you have a provision concurrency function that you know is going to live for a while, you might want to use local in-memory caching so that if a request comes to the same worker, it doesn't have to talk with the persistence layer. It can already return the previous result, which is cheaper but has different trade-offs because now you have in memory. So if the request goes to a different function, that's a problem. Similar to what I showed earlier for the event handler, we support also different types of persistence layer. Earlier I was showing you DynamoDB, but you can see that by changing a few imports, you can use a different persistence layer. For example, here I'm showing you a Redis-compatible persistence layer like Valkey serverless or any basically Redis-compatible persistence layer. So again, most of the logic, most of the code stays the same. You change some imports, and we abstract away the differences and the inconsistencies of those different layers, and you can focus on your code. Let's move now into the last topic of the presentation, batch processing. Now, if your function is being triggered by something like an SQS queue or a Kinesis stream or a DynamoDB stream, you will know that the function is called with a payload that is essentially a list of different objects. And those objects may or may not have to be processed sequentially or in parallel. Something that not a lot of people, not a lot of customers know and use and leverage is the fact that all those triggers that I'm showing you support something called partial failures. So if, let's say that you're processing a batch of records, and one of them raises an exception, the default behavior of Lambda will be to essentially put the entire batch back into the stream or the queue so that it's processed again. But if I have, for example, 5 records and only one of them failed, why do I need to process again the other 4? If you enable partial failures, you can essentially tell Lambda, hey, if I'm throwing an exception, I'm going to return only the identifiers of the items that failed so that you can consider the others as successful and remove them from the stream. But this one, or those who failed, you need to put them back, and they go through the entire retry process. And if they exhaust the retries, they go into a dead letter queue and so on. But essentially, the idea is that you don't want to reprocess things that you were already processing successfully. You want to do this smartly and only process things that failed. Again, this is somewhat complex, and not necessarily complex, but can lead to a bit of boilerplate code, because all those different triggers obviously require slightly different payloads and require slightly different identifiers. So essentially, you want to have ideally something that you can wrap your function, and you can specify, for example, a processor, or basically you want to say, I'm processing events from SQS, for example, and I am running some logic for each one of those records. This is the logic that I care about. This is my business logic that processes those items. I don't care about anything else. Just call this function for each one of those objects. If my function returns successfully, you can consider this object as successfully processed. If my function raises an exception, this item is failed. You need to put it back in the queue. And this is what batch processing essentially does for you. Similar to what I said a few times now, if you want to swap the different trigger, it's just a few lines of code. You change the import. The rest of your code stays the same. And we handle the different payloads and the different formats for you. Now, to close the session, just a few words on the roadmap. Powertools is being actively maintained, and there is a team. AWS is actively investing in it. At those QR codes, you can find the roadmaps for the main versions. Stay tuned. In the next weeks and the beginning of the year, we'll be updating the roadmap for 2025. As you might have heard by other teams, our roadmap is really defined by customer demand. So if there is something that you would like to see in any of those languages for the next year, please get in touch, open an issue, send us an email if you don't want to open an issue on GitHub, and let's discuss your use case. We would really like to hear from you. So thank you. This is the end of the session. If you have any question, I'm here to talk. If not, have a nice evening.